So the ketones involve a C double bond O, not at the terminal end of the carbon chain. If it was at the terminal end, this would be an aldehyde. So you'll find the ketones, it's an sp2 hybridized carbon, sp2 hybridized oxygen, but it's within the interior of the parent chain, essentially. So when naming them, then you'll never find them on the number one carbon on any end carbon. So typically they need to have a number associated with where you found them. So I've got an example here, a series of examples where I have 1, 2, 3, 4, 5, 6, 7 carbons. 1, 2, 3, 4, 5, 6, 7 carbons. 1, 2, 3, 4, 5, 6, 7 carbons. And you can see that in the 2 position here is the ketone, in the 3 position here is the ketone, and in the 4 position here is the ketone. So it's really important to indicate where they are. So I'm going to call this a heptan 2-one. Note that I dropped the E here because we're starting the next part here with one, so I can drop the E. This is a heptan 3-one, and this is a heptan 4-one. So remember, the positioning is quite important to this naming. If we add on a substituent that is lower priority, we can see that the ketone itself will take on the side with the number one carbon. So 1, 2, 3, 4, 5, 6, 7. So this is a heptane. So the name then becomes a heptanone again. So heptanone. We need to indicate that the number 2 carbon is where the ketone is located. We also need to indicate we now have a hydroxyl group on the 4 carbon and a methyl group on the 5 carbon. The hydroxy comes first alphabetically before methyl. So we have a 4 hydroxy, 5 methyl, heptan 2-one. And I'm going to rewrite this so I can incorporate the 2 into here. So let's get that in. So I have 4 hydroxy, 5 methyl, heptan 2-one. When naming a ketone, if we have more than one ketone, we got to keep in mind that it'll be a dione or a trione. So I've got a couple examples here. So we start 1, 2, 3, 4, 5, 6, 7 carbons. In the 2 position is a ketone, and in the 6 position is a ketone. Over here, 1, 2, 3, 4, 5, 6, 7. So in the 2 position is a ketone, in the 4 position is a ketone, and the 6 position is a ketone as well. Note that I could actually have the ketone instead of the 1 and 2, 2 and 6 position, sorry, I could have it in the 2 and 5, I could have it in the 2 and 4. So again, it's really necessary to indicate where these ketones are, keeping track of the number of what carbon they're associated with, since they're not on terminal carbons like an aldehyde or a carboxylic acid. So we have a heptane, so I'm going to say that I have a heptane, and in the 2 and the 6 position is a dione. All one word. Notice that I kept the E here because right after the 2 and the 6 I have this D dione, so I kept the E in place. And similarly, when I name the next compound, I've got a trione. So in the 2, 4, and 6 position I have a trione. So again, this is a heptane. And in the 2, the 4, and the 6 position, I have 3 ketones, so I have a trione. A couple of examples where the ketone is on a cyclic compound. So in this case here, we have a cyclohexane, 1, 2, 3, 4, 5, 6. So it's a cyclohexane, so we call this a cyclohexanone. Don't need to indicate the number that this is on because it's the only substituent, so it's just cyclohexanone. It's always going to be on the 1 carbon. However, when we start to add substituents on, as in the following example. I now have the ketone as the highest priority. I have an alcohol, and I have two methyl groups that need to be accounted for. So again, I'm going to have a cyclohexanone, but I am going to indicate what number the carbon is on. Cyclohex and 1 own. Notice I dropped the E here because I'm starting with an O over here. And then I'm going to take a look at the substituents. So in the 3 position, 1, 2, 3, I can go from this side, or 1, 2, 3. I'll end up with a methyl group 1, 2, 3, 4 on this side, or 1, 2, 3, 4 on this side. I'll end up with the hydroxyl in the 4 position. So it doesn't really matter which side I start from as long as the ketone is the number 1 carbon. And so I'm going to then say that this, in the 3 position and in the 5 position, there's a dimethyl. And in the 4 position, there's a hydroxy. So now I got to put all this together. And remember, when I put it together, the hydroxy is the functional group, the methyl is the functional group, not the D for di. That's the number of them. The methyl group is the actual functional group. So let's try putting this all together into one big long word and try to name this. So this is going to be a 4-hydroxy 3,5-dimethyl cyclohexane 1 own. And again, I dropped the E because I'm starting with an O over here. It's a bit of a complicated example here, but again, the ketone is the highest priority group. 1, 2, 3, 4, 5, 6, 7. So this is a heptane group. In the 2 position is where we'll find the ketone, so that needs to be indicated. In the 3 position is an ene, and there's a stereochemistry associated with it that we got to figure out. In the 5 position is an amine, and also there is a methyl group on it. So we got to indicate all of those. So there's a 3 ene, there's a 5 amino, but on the amino is a methyl group. So I can either say methyl amino, or I can say N-methyl amino. I'll put it in brackets because it makes it easier when you're actually naming it. And I also need to indicate the stereochemistry here. So since there's a hydrogen here, and the 2 carbons on opposite sides, they're not on the same side. That means that this is an E conformation, not a Z conformation. So if you're not familiar with the E and Z or E and Z conformations, please watch my video on E and Z naming. So that means in the 3 position then is the E, and that comes out the very front. So let's try naming this whole thing. So the very first thing I need is that stereochemistry. So in the 3 position we have an E conformation. So the amino comes first. The A comes first, and so it is, even though it's a methyl amino, so I can put, I need a dash there, N methyl amino, and then the hept 3 ene 2 own. I dropped the E here because I'm starting with an O over here. If I were to say it was a dione, I would put this E into place. So I don't have the E because of the O, and if it was a dione, for example, I would keep the E here for the ene. So let's see if we got everything. So the hep means we have 7 carbons, so that's accounted for. In the 3 position is a double bond, and not only is it a double bond, we know the stereochemistry is an E. In the 2 position is the highest priority group, which is the ketone. And then in the 5 position, right here, we have an N-methyl amino. So I've got an amino group, but on the amino is also a methyl. So that incorporates this entire name. All right, 2 more compounds to go here. So on the bottom left here, we've got the longest carbon chain, 1, 2, 3, 4. Well, notice this is not a carbon, it's not part of it, but this is an ether group. So it looks like we have an ether group hanging off. So we have 1, 2, 3, 4 carbons. This is a butane. The ketone is on the 2 carbons, so this is a butanone. So I'm going to call this a butanone. And in the 2 position is where the butane is, so it's either a 2-butanone or a butan 2-one. You'll see that this is preferred when we have more than one substituent on it. And then that means that in the 1, 2, 3, 4 position is this ethoxy. So if I were to write this whole thing out, I would say it's a 4-ethoxy butan 2-one. And that would be one way of naming it. And remember, there are 3 ways of naming ethers. There is potentially another way of naming this. So let me just show you. This is the preferred one that I have. Well, that's my preferred one. But let me just show you that there is another example that could work. And so it's usually when you incorporate the oxygen and pretend it's a carbon. So in that case, I would say it's 1, 2, 3, 4, 5, 6, 7 carbons. So this would be a heptanone. But in the 1, 2, 3, 4, 5, fifth position here is an ox-A. So I would say that this is a 5-ox-A hept and 2-one. And that is another way of writing it out. So it's a 7-carbon chain, but oops, in the 5th position, it's not a carbon, it's an oxygen. And in the 2 position is the ketone. So that is another way of writing an ether if it's necessary. In this case, it's not really. We can get away with this. It's a preferred one if we can. And the naming of this compound, again, we're going to recognize the longest carbon chain. 1, 2, 3, 4, 5, 6. But there is an aldehyde and a ketone. The aldehyde is higher priority, so the numbering starts here. 1, 2, 3, 4, 5, 6. Since this ketone is lower priority, it becomes an OXO. So in the 5 position, we're going to find an OXO. Remember over here, we said this was an OXA. This is an OXO. So remember to differentiate between the two, please. So in this case here, in the 5 position, we're going to have an OXO. And this is 6 carbon chain, so hex and al, because it's an aldehyde. We don't need to indicate it's on the 1 position because it's implied. The aldehyde is always on a terminal carbon, typically when it's the highest priority it is, for sure. And so we don't have to put in the number for it. And our last example, the carbon chain we're numbering 1, 2, 3, 4, 5. This is a pentane. Recognize that on the end group, this is an aldehyde, this is an aldehyde, and this is a ketone in the middle. So if I start numbering 1, 2, 3, the ketone is in the 3 position. If I start from this side, 1, 2, 3, the ketone's in the 3 position. Doesn't matter what side we start from. So I'm just going to start from this left side. So in the 3 position is an oxo. It's a 5 carbon chain, so it's a pentane. And there are 2 aldehydes, so it's a dial. So I'm going to say it is a 3-oxo pentane dial. I kept the E because we have this D right afterwards for the dial. If it was just a single aldehyde, if it was pentanal, sorry, I dropped the E here because there's the AL at the end. But because I have the D here, I keep the E remaining.